Well, hello, my wonderful physics students. Today we're going to learn something about our kinematic equations. Well, let's get at it. It's a fantastic shortcut to solve some problems, and I'll explain how to do it. Okay, so it's good to just jump into a problem and get some practice. So here's our first problem. A car has an initial velocity of 30 miles per hour. It accelerates at 2 miles per hour per second for 10 seconds. What is its final velocity? Well, we could say, okay, so we know that the acceleration is equal to change in velocity over change in time. We know that to be true. And this is equal to Vf minus Vi, because the change is always final minus initial, over a change in time. So we could just plug in what we know. We know that Vi is 30 miles per hour. We know that the acceleration is given to us at 2 miles per hour per second. And we know our change in time is 10 seconds. So then we could plug it into this equation here. I'm going to change it around to solve for Vf to make it a little bit easier for us. So acceleration is equal to Vf minus Vi divided by change in time. Multiply both sides by change in time. Acceleration times change in time is equal to Vf minus Vi. And then add Vi to both sides. So we get Vf is equal to Vi plus a change in time. And then we could just plug and check. So 30 plus 2 times 10. So that's 30 plus 20, which is 50 miles per hour. But we could also just reason through this. We know that since the velocity and acceleration have the same sign, they're going to have, they're going in the same direction, so it means that it's speeding up. So every second we're going to speed up by 2 miles per hour. So after 1 second, we're 2 miles per hour faster. So we start at 30, we're going to go to 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. So you could reason it out that way. You could write out your reasoning on your paper. I never want to see just an answer from you guys. I always want to see your reasoning, your line of reasoning in your work. So either way would work. Okay, so let's go to the next slide. So this is the equation that we use. This is just the acceleration is change in velocity over change in time equation, but solved for Vf. Sometimes it's a little bit easier to have it in this form as we just saw. Okay. Let's do another problem. Oh, I forgot to mention. This is our first kinematic equation. Okay. Let's do this. A child slides down a constant slope on a toboggan. A toboggan is one of those fancy sleds that you see in cartoons with the rails on the bottom. When a child passes her older brother, he estimates her speed at 2 meters per second. And when she passes her younger brother, 10 seconds later, he estimates her speed at 10 meters per second. It's a very special family that can estimate very well. How far apart are the brothers standing? Okay, so to do this problem, it's helpful to know what the child's average velocity is. It's also helpful to have a picture of what's going on. So let's draw a picture. Well, since it's snow, I'll draw snow, and then here's the toboggan. And let's see is as good as it's going to get for the little girl. Yeah. Alright, and then we draw the toboggan here, and draw the girl at the bottom. Yay, she's having fun. Okay, so she's going at 2 meters per second here, and her brother is right here, timing her. That's her brother, and then another brother will be right here, timing her, because they got change in time to be 10 seconds. Okay, and her velocity down here was 10 meters per second. Okay, so average velocity. Well, to get an average, we just add them. So VF plus VI and divide by 2. Just like a normal average. So average velocity in this case would be 10, which is our final, plus our initial, which is 2, divided by 2. So that's equal to 6. But average velocity is also, if you remember that the definition for velocity is our total displacement divided by our total time. So this is going to equal our total displacement, how far the girl went. So in the picture, change x, over her total time, which we know to be 10 seconds. So we got 6 equals change in x over 10. So we get 60 meters is equal to change in x. Woohoo! Don't you feel so smart? Okay, so if we take this equation, we just multiply both sides by change in time to get change in x by itself. Change in x is equal to change in time, and then I'll do VF plus VI, and then I'll take, instead of divide by 2, I'll just multiply the thing by half. Just make it all without fractions. Okay, this is our second kinematic equation. So let's add that to our second kinematic equations. So now we have 2 kinematic equations that we could use. Oops. They're shortcuts. Okay, so let's try this. A boat is cruising at 3 meters per second. At time equals 0, the boat begins accelerating with an acceleration of 1.6 meters per second. How far will the boat have traveled 10 seconds later? So it's very, very good to start writing out our givens. There are always 5 things that we could know about any given problem. An acceleration, an initial velocity, a final velocity, how far it went. Well, really, not how far it went, but really the displacement, which you know to be slightly different, and our change in time. So let's write out what we know for this problem. A boat is cruising at 3 meters per second, so that's the initial velocity. At time equals 0, the boat begins accelerating. That's easy, because I told us that. How far will the boat have traveled 10 seconds later? Okay. So whenever we work these problems out, we're going to have 3 numbers given to us, and we're going to have 2 blank spaces here, and I'll tell you what to do with that in a second. So, deal with that. We have our 2 equations here. Now this first equation, we have VI, we have A, and we have time, and we could get VF. But that's not what we want. what we want is how far will the boat have traveled. So this is our want, or our goal for the problem. So this is our goal. And in order to get the goal from the shortcuts that we have, we need VF. So we need to use both equations. So let's clean this up a little bit. So, well, we can first find what is the boat's velocity after the first 10 seconds. So let me rewrite what we were given. So given acceleration is 1.6 meters per second. VI is 3 meters per second. VF, change in x is our want, and change in time is 10 seconds. So if we use the first equation, VF equals VI plus AT, VF is equal to 3 plus a 1.6 times time, which is 10. So 1.6 times 10 is 16 plus 3 is 19 meters per second. And then once we have that, we can go to our second equation. Change in x is equal to 1/2 VF plus VI, change in time. And this is equal to 1/2 VF, which is 19, plus VI, which is 3, times change in time, which is 10. So 19 plus 3 is 22. 1/2 of that is 11 times 10 is 110 meters. So we can find the boat's average velocity. We can find how far the boat travels. So we can put those two shortcuts that we have together to work. Now, I'm modeling the way that I want you guys to solve these problems. I always want to see these givens right here. Always want to see these givens. I always want to see the equation that you're using written out, and then the numbers put in. I never want to see just numbers, and never, ever do I want to see just an answer. I want to see your entire work. I want to see your line of reasoning. That's what I'm really interested in. Okay, so if we take these two equations and we take this VF, right? So VF is equal to VI, or V naught, that's another way of saying VI, plus AT, and we plug it into here. In fact, this, I don't want to mess it up, so we're going to make all these V naughts, correct it out. Obviously, I did it. Okay, so if we plug this into VF, so we use substitution, and we simplify it, we get this equation. Change in x equals VIT plus 1/2 AT squared. We have our third shortcut. Now, if we do the same for change in time, we will have our fourth and final shortcut. This is our wonderful kinematic equations. And this chart you do not have to memorize. You will always get this chart from me for any quiz or test. And in fact, next class, when you come to class, I will give you this chart. So there are let's go back. So there are the four equations. And then on this side, we check which variables we have. So we have VF, so it's checked. VI is checked. A is checked. Change in time is checked. The one that's not checked is the one variable that's not used in the equation. So this equation has VI, VF, change in x, and time, but it does not have acceleration. This equation has VI, A, change in x, and time, but it does not have VF. And this one